So homework for today was to finish this dice object, right? By adding a method called roll that rolls the sided dice some number of times and returns the sum of the rolls. All right, so we're going to write a method. It's going to be a public method. And this guy is going to return an int. It's going to be a sum of a bunch of rolls. We'll call this guy roll. And maybe it takes in an int times the number of times we're going to roll that dice. All right. So then what we want to do is we want to roll. So when we first create our dice, we are bringing in a number of sides. And we're going to set this field for that dice equal to that number of sides. So when we roll, let's say the sides was 6. If I say I want to roll 3 times, I'm going to roll a 6-sided dice once, then twice, then a third time, add those 3 rolls together and return the result. Okay, so I'm doing something some number of times, and I'm going to create a sum. So I'm going to have int sum is equal to 0. Then I'm going to have a for loop. For int I is equal to 0, I is less than times, I plus plus. So this will do something times number of times. And what am I going to do each time? I'm going to randomly roll the dice. Now, we talked last time that we introduced the random object here. And we saw that we have a function called nextInt that gives us a random number in the range of all integers. And I said that was the only one you were allowed to use, because there actually is a second version of nextInt that gives you a value that you would have preferred for your homework assignment. So you had to work with a number in the range of negative 2 billion to positive 2 billion and get it whittled down to a number between 1 and sides. Make sense? So if I have a number, for example, or let me go ahead and create my random object in here. So let's say I have a number that is negative 125,213. Just random number between negative 2 billion and positive 2 billion. How do I get that value to be a number between 1 and sides? How do we get that number to be a positive number? Start with that. So int roll is equal to r.nextInt. So roll is going to be some value. Actually, we should name this something different than the name of the function. Let's call this guy curroll. So he's going to be some value between negative 2 billion and positive 2 billion. So I want to ask the question, is he negative? How do I ask that question? Good. Yeah, so you used the other version of this you weren't allowed to use.
I didn't realize that I thought by that you meant a different.
All right. Well, regardless. So I have a number. I want to know if this number is negative. How do I find out if this number is negative? Ask if it's less than 0, right? So if curroll is less than 0, if it's negative, what can I do to that number to make it positive? How do I turn a negative number into a positive number? Well, I could take the absolute value of it, but I could have just taken the absolute value of it, period, right? In this case, I know it's negative, so I'm going to multiply it by negative 1. All right, so we'll say curroll is equal to curroll times negative 1. So we'll only do that if it's a negative number. So now when we're here, we know it's a positive number. So when I get to that line right there, I know I'm dealing with a positive number. But now I need it specifically to be a positive number between 1 and sides. So for example, if sides was a 6, I want this value to get whittled down to a number between 1 and 6. Including 1 and including 6. So how do I do that? I assume we all did this for our homework assignment, right? Yeah, so go ahead.
Well, you could do your number mod 6, and then just take the remainder as your roll. That
Okay, number mod 6, so mod sides, right? Is going to give me a number in what range?
between 0 and 1 minus your roll includes.
So if it's
add 1.
add 1 to it. Okay, so he wants to do this. He wants to say curl is equal to curl mod this dot sides. And then curl is equal to curl, oh, we could have done this in the same line, plus 1. So this guy right here will whittle curl down to a number between 0 and sides minus 1. This will add 1 to that to give us a number between 1 and sides. That make sense? So now, when we're here, we know curl has been massaged into a number in the range that we want. And then what can we do with that? We add it to our sum. Spin back up. Roll again, however many times we're going to roll. Ultimately return sum. So get a random number between negative 2 billion and positive 2 billion. If it's negative, make it positive. Whittle it down to a number between 0 and sides minus 1. Add 1 to it, so it's a number between 1 and sides. Add that to our running total of sum. After we've done that, times number of times for however many times we're supposed to roll the dice, go ahead and return the sum. So I'm just going to roll it once, a couple times just to see that we're getting the right values. So I'm going to go ahead, I'm going to do system.out.println d.roll one time. So this should give us a value between 1 and 6 each time we run it. So there's a 2, there's a 1, there's a 1, there's a 6, there's a 3, there's a 5. Seems somewhat random at least. If I change this to a 20, now it's going to be between 1 and 20. There's a 12, there's a 13, there's a 16, 18, 20, 10, so on and so forth. Make sense? So now we can generate dice of a certain number of sides. Okay. Now, what if I wanted to write another version of roll that fulfilled, let's call this guy roll 2, that fulfilled the requirements of the assignment? That is, you still can't use the cheat version of nextint. How else could I have solved this problem? Go ahead.
Well, what I did was I took the last few digits of nextint, where the number of digits is equal to the number of digits in sides, and I say, all right, so is this equal to or less than sides?
Okay, what do you mean you took the last few digits?
So if like
So let's say my number was the negative 125, 112, something like that.
right, so if sides was a 2-digit number like 20, I would take the 1 and the 2 off the end there.
Okay.
And then I'd check, all right, is this,
How would you take the 1 and the 2 off the end?
I think I put it in a new string.
Okay, so because this is going to be an int first of all, right? So what you did is you converted this guy to a string by concatenating onto the empty string.
Exactly.
Okay. So now I'm able to extract these 2 buckets if I wanted to. This is length -1 and length -2. Char at those positions. All right, so you have the 1 and 2. And what are you doing with that?
Putting that in the new string, converting the string to an int, saying, is this less than or equal to sides? If it is, then I use that as my role. If it's not, then I get a new number, do the same thing.
Okay. So what's the purpose of grabbing these last? Did you always grab the last 2?
Or if sides is 3 digits long.
All right, so you figured out what's the number of digits in sides, and then you grab that number of digits from the end of the, okay? What was the purpose of grabbing the last several digits? What's the benefit of that?
Well, that'll give me a number that is potentially in the range of 0 to sides.
Okay, so why is that any better than rolling the dice over and over and over and over again until I finally get a value that's in the right range?
Honestly, it's not. It's just
Yeah, I'm just wondering why you're doing all this string. I mean, that is a weird solution. It's an A+ for weird, but I mean, it's fine. I mean,
literally, that's just what we're doing in stats with a random number table.
Okay, so you tried to mimic that.
Yeah.
So another approach here could be that you're going to go ahead and just keep rolling the dice until you finally get a number in the range that you want it, right? So we're still going to do something some number of times. So we're going to say for int I is equal to 0, I is less than times I plus plus. Okay, so this is a counting type problem. So we know we're going to go through exactly times number of times. But now each time through here, let me go ahead and give myself the sum. Each time through here, I need to get a random number, but I need to keep generating random numbers until I finally get a random number in the range of 1 to sides minus, or 1 to sides. So how many times am I going to have to roll the dice to get a number between sides and 1, or 1 and sides, however you want to think about it? What's the minimum number of times I'll have to roll the dice to get a number in the range of 1 to sides? Once. What's the maximum number? Who knows, right? Who knows how many times we're going to have to keep rolling it? Especially when we consider that we have 4 billion possible options that can pop up. And for a 6-sided die, only 6 of them are valid rolls, right? So we have 6 in 4 billion chance of winning the lottery, so to speak, which actually is a better chance than winning the lottery, but whatever. All right, so what kind of loop lends itself to something that we need to do at least once, but potentially do more than once? Almost. While loops and for loops are both pre-check loops. What does it mean for it to be a pre-check loop? Checks the Boolean expression before it executes the body of the loop, even once. So what's our other kind of loop? The do-while loop. Do-while loop says do something at least one time. In this case, we do need to roll the dice at least once. All right, so we're going to do something. So we're going to go ahead and do int. I'm actually going to define the roll outside of this. So we're going to start roll off at -1. So do, let's call this cur roll, just to match what we did before. So we're going to say cur roll is equal to, now we're going to need access to a random number generator. So let's go ahead and create one of those. Randomr equals new random. And eventually we'll start making stuff like that global so we can have random number generators that we won't have to just keep recreating them. But right now this is fine. All right, so this is our ability to generate randomness. We'll go ahead and prime the pump. Cur roll will equal, so now we're going to do something one time at least. It's going to be equal to r dot next int. And we're going to keep doing that. We're going to do this again if the thing we just rolled is either less than 1 or greater than size. Right? So we're going to keep going as long as cur roll is less than 1 or cur roll is greater than size. It's if either of those conditions are true. If it's too small or it's too big, then we're going to roll again. We'll spin back up and generate a new cur roll. As soon as we get past this, we know that we have randomly finally generated that sides in 4 billion chance of a number between 1 and sides. So we'll go ahead and say sum is equal to sum plus cur roll. And we're going to do that entire process times number of times, finally returning sum. So that's another implementation of this guy. So let's go ahead and we'll change this back to a 6. We'll call roll 2 this time. Take a little bit longer to run. Man, we're not getting very lucky. Big money. That was a lot of rolls that happened there. So now, which of those is better? Well, we can say the first one is better. The second one, depending on the quality of our random number generator, the second one might actually be more random. Because there's probably some, because of the way we're whittling down the number, there is probably some higher certainty of certain values coming out of our original random number generator, just because of the way we're whittling it down. But that makes an assumption that the random number generator built into Java is really, 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 really good. True sources of randomness are actually quite difficult to mimic. So generating, these are usually called pseudo-random numbers, aren't as random as we really want them to be. So they're not necessarily that fair. But, it should be within a reasonable margin. All right, so we probably like the first version of roll that we had here. Now, the other version, okay, the one you weren't allowed to do for your homework, but I'll go ahead and show it to you now. Public int roll 3 int times. This guy was taking a sum. We'll do something times number of times. So int I is equal to 0, I is less than times, I plus plus. All right, and then what we're going to do each time is we're going to say sum is equal to sum plus, I need to give myself my random number. R dot next int, and we're going to give it a value of this dot sides. And what that'll do is it'll give us a value in the range of 0 to sides minus 1, so non-inclusive. And then I'll add 1 to that number. So this guy right here, if sides was 6, that'll give me a number between 0 and 5. All right, so we have another version of nextInt that takes in a single integer that gives us the values. There's actually a third version of nextInt. Oh, is there not? Oh, I thought there was a one that gave you the beginning and end. No, there's not. Most languages have that. They have a, from, give me a random number from this point to this point. So we can massage this one into that if we wanted to. All right, then in the end here, we'll return sum. Go ahead and run this. This is roll 3. Should run pretty quick. Okay. Now, which is the best out of all these? Which one should you write if you were to do this again, now that you have access to this second version, and why? Can we probably throw out the keep running random numbers until we finally land on the lottery? That one seems unreasonable, right? We don't want to have to wait an hour if we're just unlucky. All right, so that one's probably out. Now, what's the real difference between my first roll method we wrote today and roll 3, the last one we wrote? How does this guy work? Is it plausible that what we have written right there is actually that stuff? Somebody wrote that function, right? We already had the ability to generate a number between negative 2 billion and positive 2 billion. Is it plausible that Java just included a helper function that went ahead and did the whittling down for us? Just because that's something that you might want to do fairly often? I mean, generally when we're generating random numbers, we're probably generating numbers between 1 and something for some sort of statistical whatever. Now, every now and then, if you just want a whole bunch of random data, you might want to just have giant numbers in the range of negative 2 billion to positive 2 billion to just fill up something. So they kind of both have purposes. But realistically speaking, this guy here is just a convenience method. It's possible that the way they've implemented might be a little bit higher performance than what we've written. But generally speaking, that little shortcut just does the little math tricks we've done here to whittle it down. Does that make sense? So the punchline here is that we didn't need to know about this specialty version of this function in order to accomplish this assignment. It made life a little bit easier if we happen to know about it. But and this kind of comes back to how we go and solve problems. We always have to solve problems in terms of the tools that we have sitting in our toolbox. And now with that in mind, if you haven't learned about something yet, and you can think, if you can sit down and write it yourself, for right now, your best bet is to just go ahead and write it yourself. Don't go on this journey through Google looking for the function that just happens to solve the exact problem that you want to have solved. A, you're actually doing yourself a disservice because you're not getting to practice your logic puzzle stuff. Okay? Now, once you become maybe a little bit more accustomed to programming, you might be able to make a reasonable guess as to whether something might be built into the language or not. So for instance, in this case, if you're an experienced programmer and you say, look, I can write this, but why should I if there's something already in there? It makes sense that there's probably a function for getting something between the range of 1 and some upper limit. Let's just go and get the syntax for that real quick. That makes sense? All right, now she mentioned something about absolute values. So effectively, in my original roll method here, isn't that if statement effectively taking in the absolute value? Isn't it calculating the absolute value? So if I wrote a little function in here, public int ABS, and I took in an int val, and I ask if val is less than 0, val is equal to val times -1, and then go ahead and return val. Isn't that effectively the absolute value function? Take in a number, ask the question, is the number smaller than 0? If it is, multiply it by -1. Go ahead and return the value. Potentially modified, but potentially not modified. This is absolute value, isn't it? Is this a class method or an instance method? Instance method. How do you know? It's getting worse. Yeah. What was the last part you said? Not static. Not static. Out of all the gibberish he was babbling there, the only important part that he said was the not static part. All right. The fact that this was not static, so don't worry about the integer stuff and all the other garbage. But the fact that it's not static is the reason we know it's an instance method. All right. How do we call instance methods? Using an instance of the class in which the method was defined. Okay, so what was the name of the class this method was defined in? Dice. So I need an instance of the dice class. So because I've worked really, really, really hard writing my own little absolute value function here, I want to be able to call that function. So rather than this code right here, I want to be able to call my absolute value function. I want to be able to say cur roll is equal to the absolute value of cur roll. How do I call my instance method? Of dice called ABS. I need an instance of the dice class. Do I have an instance of the dice class in here? Here's my current scope that I'm looking at. Ah, he redeemed himself. I do have an instance there. We don't see it, but we have that keyword this dot ABS, passing it cur roll. This is an instance. In fact, it is the instance of the class that you're currently in. This keyword, this is how an object refers to itself from within itself. All right, now let me give you evidence of this so we can see it. If I come back out to driver here, I have my dice D. I'm going to go ahead and print out D. What's going to print out here? What will this print? Memory address thingy, right? Okay, so let's just prove that real quick. Okay. Why does it print out a memory address? Give me some explanation for that. All right, so this guy's an object. He was built using the new keyword. So D is a variable that actually holds a pointer to where that object actually lives in memory. So this is the address of that guy up in memory, correct? All right, now, right here I'm calling D.roll. So that's going to take me, that's taking D, my instance of the dice class, calling his version of roll 3, which is going to take me into here. So now I'm sitting at in role 3. I'm right in here. I no longer have access to that variable called D. Does that make sense? I am within D. Okay? I'm inside of that object. So that object needs to have some way of referring to itself. I'm going to go ahead and the very first thing I'm going to do here is I'm going to print out the value of this. So I've advertised that this is how an object refers to itself from within itself. What kind of value is going to print from this? Another memory address? Same memory address. This in here is a synonym for D out here. They both point to the same place. Identical memory addresses. Does that make sense? So that's proving that this is how an object refers to itself from within itself. Because D, this variable that we defined out here, its scope lives and dies with main. Once we jumped into the roll3 function, which lives inside of dice, this instance method, once I got in here, I no longer have that variable D. So I had to have some way of getting back to, some way of referring to who called me, the dude who called this method. And I do that with the this keyword. Does that make sense? That lesson right there is in your top 5 most important things for understanding object-oriented programming. Okay? You need to be able to completely wrap your mind around that concept because you're going to use this all the time. This is how an object refers to itself from within itself. Dice D2 is equal to new dice 20. What will D2 print out here? Cat, dog, or memory address? Memory address. Will it be the same memory address as D? We hope not, right? We ask the operating system, give us a memory address, give us a place to put D2. Now, what we wanted to happen here is that D and D2 are separate variables. They live in separate places. We've built 2 different dice objects, so these guys should have 2 different memory addresses. So the first 2 things we see here should be different memory addresses. The first one is D, the second one is D2. Now, if I were to call D2's roll method, even though it's the same roll method, the second one is the one that belongs to D2. So his version of this variable should match D2's memory address. There's D. There's this within D's call to roll3. Here's D2. Here's this within D2's call to roll3. Make sense? They are synonyms for each other. Okay. Now, because of that, I can call, where was I actually writing the absolute value thing? This.abs cur roll. Now, does this absolute value function change whether I'm inside of D's version of ABS or D2's version of ABS? Does the output of that change at all? No, it's like a little machine, right? So does every single version, does every instance of the dice class need to have their own absolute value function? Or is it okay if that guy just exists once? It's okay for him to exist once. We just need a little tool. We need the ability to calculate the absolute value. So with that in mind, couldn't I make this guy static? So now we're kind of thinking about why would we make a method static versus not static. So now this guy is a class method, right? Because we have static in front. How do we call class methods? Using the name of the class. So now I would say dice.abs, curl. That method, that ABS method, only exists one time across all dice objects because it's not owned by an individual instance of the dice class. Instead, it's owned by the class itself. It only exists one time. That make sense? Okay, now let's go to the Java documentation. I'm going to introduce a class to you. It lives inside of java.lang, the core language, and it's a class called math. So in this math class, we have a whole bunch of stuff. We have a couple of static fields, the value of e and the value of pi. We have absolute values. We have multiple absolute values that can take the absolute value of a double, a float, an int, or a long. So here's the method called ABS. It takes an integer as a parameter. How do I call this method? Math.abs. Why? Because this is a class method. How do we know? Because it has static out front. So it's a class method. How do we call class methods? Using the name of the class in which the method was defined. This method was defined inside of a class called math. So I will say math.abs. And then I can go ahead and get rid of my version of this guy. Not that it was wrong. But if I happen to know that there's already a class out there for doing a whole bunch of mathy things, I can go ahead and call upon that class to get the absolute value. That make sense? So we see we have a whole bunch of like sines and cosines and things like that. All right, so a lot of different mathy stuff exists inside of, here's another one if you want to get the maximum of two numbers. We could write that ourselves, right? You know, if A is greater than B, return A, else return B. It's just built in there for us, so we can have a quick little call to generate the maximum, figure out the maximum value of two numbers. Same thing with minimum. Same thing with getting the power. Here's another version of random. This returns a double value with a positive sign. So it's always going to be positive. It's going to be greater than or equal to 0, and it's going to be less than 1. So this would give me a double number, a floating point number between 0 and 1, not including 1. That might come in handier. We might prefer that over the random class. So let's say, let's just come back out here. So there's math.random. That's going to give me some number between 0 and 1. So there's the number it gave me, 0.58. Let's say I want that number between 1 and 10. How do I take that math.random number and turn it into a number between 1 and 10? Go ahead.
Multiply it by 10 and then you can cut off some of the digits if you want to take out that 3
Okay, so I can multiply it by 10. So now I have a number between 1 and 10, except I have some extra stuff. All right, how do I cut that off? So I can turn it into the string, and then because I know it's a number between, well, technically it's going to be 0 and 9, I need to now find the place where the decimal point is and only return everything before that. So I could write a little static get before decimal. Takes a string as a parameter, and this guy is going to have a new string called answer. And we want to go through and locate the decimal point. And everything up to, but not including the decimal point, we want to build on to our answer. So potentially we're going to go through the entire string. For int I is equal to 0, I is less than s dot length, I plus plus. We'll ask the question. I want to know, does the character I'm currently looking at, is that guy the decimal point? How do I ask that question? What's the character that I'm currently looking at? How do we access that guy? Char at which position? I. And char at is a class method or an instance method? Here, if it'll help. It's an instance method. Here, let's just connect the dots there. So I'll go into the string class. We'll go down to char at. Here's char at right here. No static. It's an instance method. How do we call instance methods? Using an instance of the class in which the method was defined. I need an instance of the string class. I happen to have one right here. So I'll say s dot char at I. So that will give me the character at position I in S. And I want to know if that guy is the same as a decimal point. How do I ask that part of the question? Okay, double equal sign, is that okay to use here? This guy is the equivalence operator and it works for what kinds of things? Cat, dogs, primitives, or objects? Which one was it? Primitives. So this is the primitive equivalence operator. What kind of value is this boiled down to? Primitive or an object? It's a char. What kind of thing is that? Is that a primitive or is that an object? Primitive. So if this guy's a primitive, am I okay using this? Yeah. It's the appropriate equivalence operator to use here. So notice, even though S is a string, S dot char at I boils down to a char. That's the return type of that guy. And a char is a primitive type. Therefore, if we want to compare it to another value, another primitive type, we would use the equivalence operator just like this. And what am I comparing it to? How do I write decimal point as a char? That guy? This is the char representation of a decimal point. All right, so if I'm looking at a decimal point, that means I have reached the end of the line, and I should go ahead and return answer. Otherwise, I'm going to say answer is equal to answer concatenated with s dot char at I. I'll just start building up my answer. Now, notice here, and this guy expects a return type. Notice here that this guy's still not happy. We know that we are only going to pass decimal type values in here. But why is this guy currently not happy? Doesn't the logic look fine? Why do you think he's not happy? I've advertised I'm going to return a string. Is an answer a string? Is an answer a string? What kind of loop is a for loop? Pre-check or post-check? Pre-check. What does it mean to be a pre-check loop? We ask this question before we ever execute the body of the loop. Could this be false right off the bat as far as Java is concerned? We know that it won't be because we kind of know what kind of stuff we're going to throw into the this function. Kind of like you wouldn't throw rocks into your blender, but you could. Make sense? All right, so we happen to know how we intend to use this function, but Java has to deal with this generically. So as far as Java is concerned, this guy might be false the very first time. And even if that wasn't true, let's say this was a do loop, which does execute at least once. Is there any guarantee we'll ever get inside that if statement? We have two potential walls here blocking us from our one return statement. So as far as Java is concerned, even though we know we'll always give it a string that has length, and even though we know we're always going to give it a string that has a decimal point in it, as far as Java is concerned, both of those conditions might keep us from ever getting to this return statement. So the reason Java's not happy is that we have not written this code to guarantee that a value will be returned. Because we've advertised the return value here as string, we must guarantee that it will return a string. That make sense? So we can come down here, we can return answer, we can return the empty string, whatever we want to do. Now Java's happy with it, even though we know it didn't change the functionality of this based on how we intend to use it. That make sense? Another important concept. There's a difference between how Java is going to interpret our code and how we intend to use that code. So this guy is going to be a string. That's going to be a value between, well, really, it's going to be a value between potentially, is it always going to have at least one number? This is never going to actually get us to a 10. This is always going to be a number between 0 and 1. So the biggest number it would ever be is 0.99999, which would give us a 9 point something. Well, let's assume we're dealing with a number between 0 and 9 then. Yeah, we can. We'll have to look back at the math class in a second to figure out how to round. All right, so we have that guy. I'm going to go ahead and I'm going to say, this is a class method, so I'm going to say driver.get before decimal. Here's my string. And there's my 2, 3, 1, 4, 1, 4. So that's seemingly getting values before the decimal. We haven't, this won't allow us to get a 0, and it won't allow us to get a 10, as it's currently written. We do have the ability to round. So one thing we can do is we can say, if we go back into the documentation here, we'll see that inside the math class, there's a round function. So here's the one that takes an int, returns the closest int to the argument with ties rounding to the positive version of the number. All right, but what if we wanted to write our own round? So this guy's going to take in a double. So the number that comes out of math.random. And it should return a value that is that double. Well, to return a value that is 0.5 and up takes us to the next number. Less than 0.5 takes us to the bottom number. How do we figure out what the difference is between this double? So if we assume this double is something like 3.47, how do I figure out that that guy is actually should be a 3? How do I get the 0.47 from that and treat it as a number? See, this becomes kind of these interesting problems. These are all things that are pretty easy for us to do as humans, right? It's like, oh, 3.47, just subtract 3 from it. We got 0.47. Is 0.47 less than 0.5? Yep. So answer's 3. If it was 3.52, the answer would be 4. Real easy for us to do as humans. That's the problem we're solving, right? But now I'm giving you a num called num that holds some double value. How do we determine if that double value should be rounded up or rounded down? Let's start off with the first part of this. How do I tell the difference between this value and how do I tell the difference between a 3.47 and a 3? How do I get the 3? Well, I'm talking about inside this function. Num is some value. I want to get num without decimal places. That's what I'm really asking.
Would the integer version of that double just be 3? Like if we
Typecast?
typecast.
Yep. So we can go ahead and say double, maybe call this guy flat, is equal to the integer version. Well, actually, let's do it as a couple of things. We'll say int flat is equal to the integer version of num. And what that will do is it will truncate num. So if num was 3.47, now flat will be 3. It cuts the decimal point off. Make sense? All right. So now I'm going to say double diff is equal to num minus flat. That'll give me the difference. Then I want to know if diff is greater than or equal to 0.5, return flat plus 1. Otherwise, return flat. Is that rounding? So there's val. And there's the rounding of val. 9.9 became a 10. 2.5 became a 3. 2.75 became a 3. 1.6 became a 2. There we go. 8.22 became an 8. So did we just write round? Not too bad, right? But this is all using little manipulation tricks. We're kind of taking the knowledge that we have of our various types through typecasting, through things like that. We're able to whittle this down. Now, let's keep this interesting. Let's make this more interesting. What if I said you had to implement round, but you weren't allowed to typecast? Wasn't this guy right here a pretty integral part of what we just wrote? Okay, but now we've taken typecasting off the table. We've added that constraint for no good reason other than I'm mean. Okay, you also can't use the math.round function. Okay, can't use that one. Extra mean. So how could we solve this? What's an alternative solution to this problem?
Divide it by 100.
Okay, you want to divide it by 100? So what kind of value will I get if I divide val by 100? I know that val is going to be a number between 0 and 1. Some decimal number between 0 and 1. So now I'm getting the 0.0 value.
Actually, it'll be 10 on it.
You want to divide by 10?
So multiply by 100.
Multiply by 100 gives us a number that looks like that. If I divide by 10, I get a number that looks like this. Is that really what's after the decimal place? Let's print out val. That didn't give us what was after the decimal place. Just move the decimal point. So how do we do this? Well, it's a reasonable question to ask. You want to know if modulus does anything. Okay, so what do you want to mod by what? Or you just want to use modulus? Just throw modulus in there and see what happens. I want you, so obviously I've picked a problem that, well, you at least all hope it's solvable, right? I promise you it isn't solvable in a super easy way, but none of the individual parts are difficult. You're going to have to do several things to this to get the answer. But what I've done is I've said, here's a box of tools. And then here's the couple you're not allowed to use. Solve this puzzle. Now, we like those kind of games, right? Until we can't solve it, then we get all ticked off. Like when you go to, what's the name of that restaurant that has the Cracker Barrel? They have those like the old-fashioned puzzle toys things where you basically just try to bend the metal to finally get it apart. You know what I'm talking about? Those little, yeah, I hate those. Then my wife can walk up and just solve it like in 5 seconds. Like it almost just falls apart in her hands. So these are kind of interesting puzzles for us to solve, but we're exercising our ability to use these tools. So using the tools you currently have in your basket, how could we rewrite round if we're not allowed to use math.round and we're also not allowed to use we can't use typecasting to an int to give us the truncation trick.
Did you write this before decimal?
Who?
Decimal, the function below. Right there. That takes anything up before the decimal. Right?
Correct.
Just use that.
But it gives it to me as a string.
You can convert it.
Okay. We're all right, we're getting there. All right, so he wants to say, well, can't I say driver dot get before decimal? This takes in the string version of val. So I'm actually going to do empty string concatenated with val. Turn val into a string real quick. So this gives me the string version of val. And I'm going to say give me everything before the decimal point. So now I have that. But this dude is a string. How do I get that 0.9 part? Do I need to turn this guy back into a number? Well, now hold on. We're not guaranteed that this is a single digit number, right? Well, I guess in our example right now, it is. But if we want round to really work, that potentially could be a number in that range, right? We want round to work on any sort of values. So we're not guaranteed that the number before the decimal point is a single digit number. It's a number, right? And we want to round that number. So now I have 342 as a string. And what we really want is this 0.66 thing. So if we could somehow figure out how do I subtract this number from this number, giving me the 0.766. But the issue is that I have the 342, the second thing here, I have that as a string. How do I make that a number? We're just asking one tiny little question at a time. If I have the string representation of 342, how do I make that into a number? Huh?
Can we use bars? Integer bars.
Yeah, we haven't introduced that yet. But it would be great if we could. Not in the toolbox.
Can we write bars?
You can, but I actually am thinking we maybe have already written this. We've actually written this exact function we need. We just didn't call it something that made it stand out as being the. Go ahead.
Like an index up. You had a string and then returning that.
It's going to be a long string. What base is this number in? Base 10? Did we write something called base to decimal? We wrote that, right? If we passed it a string, and that took a string as a parameter along with the radix. So if I passed this dude to it and said this is base 10, would it give me 342 as an int? It would. Let's jump back into Slack here. How many things ago was it? That's isval. That's the binary to decimal, decimal to binary, so it's probably this one right here. Here's base to decimal. Right there. So we can bring this guy in here. We have base to decimal takes in a string representation of a value, the radix that's in, and it spits out an int. So can I say driver dot, let's store these in individual variables just for the sake of practice. So I can say string trunk num is equal to that, right? So that's going to be the string representation of our value of everything before the decimal place. Trunk num as int will be driver dot base to decimal trunk num base 10. We'll go ahead and print out trunk num as int. Oop. Oh, get in from jar. We got to bring another guy in here. How do I view the whole thing? There we go. Get it from char. So there's our 365. And just to prove that that guy is an integer, we'll go ahead and add 1 to it to show that it does a mathy thing, not a concatenation thing. Trunk num. So 591, 592 was an int. Now can we go ahead and call our round? By changing flat to the result of all this stuff. So there's num. There's flat, and then the rest of it should be the same. So driver.round val. There's our 204. 823 rounded up from 822.86. That makes sense? Now remember something we said before. We said that Java is a string-based language. Strings are very malleable in Java. So by getting that guy into a string, we were able to manipulate it and kind of pull stuff out of it. Now, we happen to remember that we had a conversion tool that did this for us. Okay. Now, what you've pointed out here is that we actually do have a function. If I didn't want to have to do all of this stuff, I could actually get before the decimal point that gives me a string-based number. I can then replace this guy. So let me just show you an alternative. So rather than using our driver base to decimal, I'm going to say we have an integer.parseInt function. And I'll pass the string representation of our number, and this guy will effectively juice it into the integer version of that same number. It'll do the same thing we just wrote. So there's the same result. That makes sense? So now we have access to that tool to convert a number. All right, questions about any of that? All right, so now what I'm going to introduce here in just our last few minutes is collections. We're going to write a array of stuff. So let me get rid of this. So I'm going to create an int array called AR, and this guy's going to be a new int array capable of holding 10 elements. Okay? Then I'm gonna go ahead and give myself the random number generator. I'll say for int I is equal to 0, I is less than AR.length, that's the number of buckets in AR. I++, so this is kind of like the lists that we worked with in Python, although these are less flexible than lists. And we'll talk about kind of how they work under the hood next time. So I'm giving you a tool. You don't necessarily know how that tool is built yet, but I'm going to ask you to solve a problem using this tool. Okay, so int I equals 0, I is less than ar dot length, I plus plus. Then I'll go ahead and say ar at bucket I. So I'm going to store inside of bucket 0, store inside of bucket 1, store inside of bucket 2 some value, r dot next int. So just random numbers between negative 2 billion and positive 2 billion. So this code here, fill up the array. Print the array. I'm just going to go backwards just to show the, where the endpoint is. Arrays are indexed just like strings. So I'll say for int I is equal to ar.length minus 1. That's the last legal position in the array. Notice, though, that this guy is not a function. He's actually a field. He's just a variable. All right? So it changes the way we call it. We don't have the opening and closing parentheses. So we'll start off at the last legal position. We'll keep going as long as I is greater than or equal to 0, 0 being the first legal position. We'll subtract 1 from I each time. And then we'll go ahead and say system.out.println ar at bucket I. So this will fill my array forwards, and this will print the array backwards, showing how we can put stuff into an array and how we can display stuff that's already been loaded into an array. Go ahead and run this, and we have our 10 numbers that are stored in that array. If I want to change one of the values just real quick, I'm just going to set ar at bucket 0 equal to 0. So we'll just zero out bucket 0. Pretty good chance it wasn't a 0 to begin with. There's our 0 at bucket 0. So that's how you can modify an individual bucket. Okay? So your homework assignment now is to update our roll method such that it returns an array of the individual roles rather than the sum of all roles. Make sense? So build an array that's big enough, roll the dice so many times, load those rolls into the array, spit the array back out. Questions, comments, concerns, bribes? All right, I'll paste this code up there. I'll put the assignment up, and I will see everybody on Thursday. Don't forget, student, faculty, staff, Bible study today. God and grub. Just go to the cafeteria, sign in. You get free lunch. Take it down to the terrace room at noon. We will. I'll put that up today too.